Hi guys! Today, ang pag-uusapan natin is yung tinatawag nating Bernoulli's Energy Theorem. We will try to make this discussion easy to understand, easy to remember, informative, and complete. And when I say complete, what I mean is that we are not just going to discuss yung Bernoulli's Energy Theorem, but we are also going to solve some problems para may apply natin yung mga matututunan natin tungkol dito sa ating subject ngayon. So, this topic is really important dahil kapag nagsimula ka ng pag-aralan yung fluid mechanics and hydraulics, hindi maaaring hindi ninyo pag-aralan itong Bernoulli's Energy Theorem. Okay, so let's start by explaining kung ano ba tong definition ng Bernoulli's Energy Theorem. So, yung Bernoulli's equation, it states that an ideal fluid, which means having zero viscosity, constant density, and steady flow, the sum of its kinetic, potential, and thermal energy must not change. So we are going to explain that later, no? If you are going to check yung book na isinulat ni Christy Ginkoplish, yung Principles of Transport Processes and Separation Processes, merong mga special cases na binanggit doon kapag you are going to apply yung Bernoulli's theorem. So, in Bernoulli's energy theorem, there is no mechanical energy added. So, that means our shaft work is equal to 0. And also, there is no friction. So, the summation of all the friction is equal to 0. So, anong ibig sabihin nitong sinasabi dito na the sum of its kinetic, potential, and thermal energy must not change? So, dapat daw hindi nagbabago yung kinetic and potential energy. So, let us try to analyze itong figure na nasa harapan natin ngayon. As you can see, a fluid or a liquid is flowing on this pipe. No? So, this is our pipe. And let's say, para hindi na tayo mahirapan, this is a stream where ang dumadaloy is tubig. No? So, paglabas nito sa pipe, sinasalo siya ng another container, no? So, our point 1 here is itong end ng ating pipe kung saan lumalabas yung ating liquid. And then, ang ating point 2 is itong sumasalo ng ating liquid water, no? Then, let's say, it is again flowing to another container here, which is our point 3. Okay, so now, i-analyze natin yung sinasabi dito na the sum of its kinetic and potential thermal energy must not change. So what it basically means is that, okay, we have to remember this condition. If the flow is continuous, so this is true as long as we have a continuous flow. So as long as the flow is continuous, energy at any points are equal. So, let's say we have point 1, point 2, and point 3 here. So, if energy is equal at any point, provided that we have a continuous flow, so that means our energy at point 1 is equal to energy at point 2, and is also equal to energy at point 3. So, basically, yan ang sinasabi ng Bernoulli's energy theorem. So, madali lang siya matandaan, no? As long as we have a continuous flow, and it meets this special conditions or cases, our energy at any given point are equal. Okay, so if you already watched our previous video about energy and head, and also our video about overall energy balance, so you will be familiar with this equation here. We are saying here that energy or the total energy is equal to potential energy plus kinetic energy. So, we're going to have a short review yung mga napag-usapan natin before. So, we already stated sa ating previous video that potential energy can be in two forms. So, okay, so yung isa is yung energy stored due to pressure. Okay, so meron tayong internal pressure na i-consider for potential energy. And potential energy can also be an energy due to elevation. So, ito yung position ng ating fluid relative sa given datum point. Okay, so we already discussed that, but we are going to explain that again dito sa video na to later, no? And then we have the kinetic energy, which is the energy dependent on the velocity of the fluid. Okay, I'm sorry, this is on, okay, which is dependent on the velocity of the fluid. Okay, so to make it clear, our potential energy can be due to internal pressure, no? So we can say this is potential energy. Then our energy due to elevation has a notation of Z. And then we have here our kinetic energy. So writing this way, you will have here energy is equal to PE, which is the energy stored due to pressure. So we call that the pressure head. And then the energy due to elevation is what we call the elevation head. And the kinetic energy, which is the energy dependent on the velocity of the fluid, is what we call the velocity head. Now, we are talking about head. Okay, so if you will watch again our previous video about energy and head, you will understand that we are representing energy using a unit of meters, di ba? So how can that happen, no? We are representing it in meters, but we know that energy is expressed in a unit of joule, or this is also equal to Newton meter, di ba? And our pressure head, okay, this is pressure, so this is in kilopascal. Our pressure is in kilopascal. So, kailangan lahat ng unit ng ating energy rito, potential, kinetic energy, lahat yan ma-express natin in meters. And maging itong energy natin, dapat ma-express natin in meters. How can we do that? You can do that because Bernoulli's energy equation, which is BEE, is expressed in energy per unit weight. So it is not just energy. If we are using Bernoulli's energy equation, it is energy per unit weight. So it is not in joules. It is expressed in meters. Paano yon? Let us try to consider this example here. So this is the volume of water having a weight of 1 Newton. Okay, so anong energy meron dito sa ating 1 Newton ng water? So let us say we know the energy that is stored dito sa ating 1 Newton of water. So the energy is having a unit of joule, okay, or Newton meter, no? So we have Newton meter unit. So now, what do we mean by energy per unit weight? So in 1 Newton of water, we will have energy based from Bernoulli's energy equation will be Newton meter divided by 1 Newton of water. Okay, so in this case, our unit for Newton will be cancelled out. So ang matitira sa atin is yung unit na meter, no? So our energy actually will be expressed in meters kapag dinivide natin siya sa unit ng water natin or yung unit weight ng ating fluid. Okay, so we have to understand that when we use Bernoulli's energy equation, we are calculating the energy per unit weight. Kaya lahat ng unit natin dito will be in meters. So, ngayon alam na natin that this will be in meters. Okay, we already know that based from this because yung energy kapag dinivide natin sa unit weight, you will have meters as a unit. Okay? So, how about itong potential energy natin, itong pressure head at elevation head? How can we have that unit? So, first, let us understand ano ba tong pressure head. So, ang sabi natin kanina, pressure head is an energy stored due to pressure. So, may mga bagay tayong kailangan tandaan when we are solving problems in hydraulics, no? First is that we have an internal pressure when we have a closed container. So, most probably, kapag meron tayong closed container, we have a internal pressure. That's why in this example, naglagay tayo dito ng pressure gauge. This is to indicate na meron tayong internal pressure dito. Okay? So, that means here, we have pressure. Okay? So, meron tayong pressure dyan dito sa loob ng container. And also, kapag nasa loob siya ng pipe, let's say at this point, okay, let's say this is our point 1, on this point, we also have an internal pressure. Inside the pipe, we have an internal pressure. But what happened kapag na-release siya sa atmosphere? Like for example, this is our point 2. Okay, we have to remember that if the fluid is subjected to atmospheric pressure, our gauge pressure is equal to 0. We have to remember that. The easiest way to visualize this is that dito meron tayong internal pressure. And that pressure is causing this fluid to flow outside. And dito sa loob ng pipe, meron ding nag-a-act na pressure. Okay, di ba? Nagkaroon nga tayo ng previous video on how to calculate the pressure at different elevation, di ba? So we have a pressure at this point. However, kapag na-release na natin siya sa atmosphere, we can visualize it that on this point, our fluid was released from the pressure. Okay, so yung pressure natin dito is no longer acting dito sa ating fluid once it is exposed to the atmosphere. So to be clear, dito sa point 1, our fluid is not subjected to the atmospheric pressure, but rather it is subjected to the internal pressure. So yung pressure dito sa ating system. But once it was released to the atmosphere, naging malaya yung fluid natin. So it is no longer subjected dito sa ating internal pressure. Okay? So I hope you understand that. So that is why if it is subjected to the atmospheric pressure, our pressure gauge is equal to 0. Okay? So that means if we have an open tank container here, that means this whole area is subjected to atmospheric pressure. So if this is our point 1, so here our pressure gauge is also equal to 0. And in our point 2, since this is also released to the atmosphere, our pressure here is also equal to 0. Now, one thing na dapat natin tandaan when we are solving problems involving pressures dito sa ating hydraulics or fluid mechanics course. Kapag meron tayong container or a vessel at nakakita tayo dito ng small triangle, it actually means that this surface is exposed to the atmosphere. Okay, so meron tayong atmospheric pressure na nag-a-act dito sa ating fluid. So you have to remember that kapag nakaka-encounter kayo ng triangle dito sa ibabaw ng ating surface. Okay? So sabi natin kanina, if we are dealing with pressure, our unit is in kilopascal, di ba? So kailangan natin makuha is yung pressure head, which is in meters. So how are we going to convert our units? So alam natin kanina, ang sabi natin, when we are working with Bernoulli'S energy equation, we are not getting energy, but we are getting energy per unit weight, di ba? So our energy here, which is potential energy due to the internal pressure, so our energy is equal to pressure divided by the unit weight. Okay, so napag-aralan na rin natin to in our previous video. So if we are working with this equation, that means our energy, okay, what is the unit of pressure? Pressure is force per unit area, di ba? So newtons per square meter divided by what is the unit of our unit weight. So our unit is having a unit of newton per cubic meters. So what does it mean? This is equal to newton per square meter times cubic meters per newton. Okay? So having that, we have our newton on numerator and denominator. So this will be cancelled out. Then we have square meter here, which will be cancelled out. Ang matitira sa atin is meters. Therefore, our unit in our pressure head will be in meters. Okay, so we are clear now here. Our unit is in meters. How about in elevation head? So in elevation head, wala tayong masyadong problema because we are talking about location here. So it is already in unit of meters, di ba? So this is already in meters, so wala tayong problema. But how do we apply itong ating elevation head? So looking at this example no sa ating illustration, equal ba lahat ng ating elevation head? No, because since this is based from distance, if our datum line, let's say, is on this point, okay, so let's say this is our datum point. So that means our energy due to elevation is higher in point 2 and it is higher in point 1. So that means if we are talking about elevation head, our energy in point 1, okay, potential energy due to elevation in point 1 is greater than energy in point 2 and it is greater than energy in point 3. Okay, so I hope clear to sa atin guys, no? So once again, if we are talking about elevation head, we are talking about the position of our fluid. So dahil mas mataas ang position ng ating point 1, so that means it has a higher potential energy. And since mas mataas naman itong point 2 kaysa sa point 3, mas mataas ang potential energy nito due to elevation compared dito sa point 3. Okay, so dapat malinaw yan sa atin. So ang natitira sa atin is itong kinetic energy, no? Yung velocity head natin. So paano magiging meters ang unit niyan? So we know that kinetic energy is equal to 1/2 mv squared, no? So nalaman na natin to even in our P6 class. We know that kinetic energy is equal to 1/2 of mass times the square of the velocity. Okay, so we know that weight is equal to mass times the acceleration due to gravity. So therefore, we can convert this mass into weight, no? So we have mass is equal to weight over the acceleration due to gravity. So substitute natin yan dito. So we have kinetic energy is equal to 1/2 times weight over acceleration due to gravity times velocity squared, no? Okay. So sabi natin kanina, when we are using Bernoulli's energy equation, we are not just getting energy, we are getting energy per unit weight. So we are going to divide this by the weight of the fluid. So we have kinetic energy divided by weight. So we have here 1/2 weight over acceleration due to gravity times velocity squared, okay? We are going to divide this by the weight, okay? So dinivide natin sa weight itong left side ng equation. We have to divide also the weight on the right side of the equation. So this will be cancelled out. Okay, so our kinetic energy dito sa ating Bernoulli's energy equation is equal to velocity squared, this is our numerator, divided by 2g. Okay? Okay, so if we are using this equation, that means our kinetic energy per unit weight, which is velocity squared over 2g. Ano yung magiging unit natin? Velocity is meters per seconds, but this is squared. So we have the unit of our acceleration due to gravity, which is meter per second squared, no? So this is acceleration, so we have meter per square of the time, no? So we have meter per second squared. Okay, so that means we have here meter squared per second squared, and we have here meter per second squared. So which is also mean we have meter squared per second squared times second squared per meters. So ano yung mangyayari sa unit natin dito, no? So our second squared will be cancelled out, this meter will be cancelled out, ang matitira sa atin is in meters. So therefore our unit here will be in meters, no? So let us update our unit here. Now we know that our kinetic energy here will also be in meters. Okay, so now let us apply that to our Bernoulli's energy equation. Sabi natin, in using Bernoulli's energy equation, as long as we have continuous flow, our energy at all points is equal. Okay, so they are all the same. So our energy at point 1 is equal to energy at point 2, and it's equal to energy at point 3. And we know that energy is equal to the pressure head plus the elevation head plus the kinetic energy, which is the velocity head. And all of this will be in meters. So, using this concept na natutunan natin, that means our energy is equal to our pressure head. Anong formula natin kanina sa pressure? It is pressure divided by the unit weight, no? Plus our elevation head, which is Z. Okay? So this is the energy due to position of the fluid. Plus our kinetic energy or the velocity head. So ano yung formula natin sa velocity head? Ito, V squared over 2G. So we have here velocity squared over 2G. So this is the formula for energy, or what we also called sa ating previous video as the total energy. Okay, so having this, it means that energy at point 1 is equal to pressure at point 1 over the unit weight plus the potential energy or elevation head at point 1 plus velocity at point 1 squared over 2G. While in point 2, the energy at point 2 is pressure at point 2 over the unit weight plus the elevation head at point 2 plus velocity 2 squared over 2G. So since energy at point 1 is equal to energy at point 2, that means we have pressure at point 1 over unit weight plus elevation head at point 1 plus velocity at point 1 squared over 2G. So this is equal to pressure at point 2 over the unit weight plus the elevation head at point 2 plus velocity squared at point 2 over 2G. Okay, so ito yung equation na ginagamit natin, no, when we are working with Bernoulli's energy equation. So we are able to derive that now. You can also derive it as per what you have learned dito sa ating lecture, no? Madali nyo na siyang madederive because you know how the concept work. But of course, in order to understand this clearly, we have to solve some problems. So let us start with this problem here. So ang task natin is to calculate the energy flowing in the pipe. So let's say we are talking about this point right here. Okay, so gusto natin malaman kung ano yung pressure dito, no, sa loob ng ating pipe. So we have water flowing on this pipe. So given ang ating gauge pressure, given ang velocity, and given yung elevation, no, kung yung position ng ating fluid from the ground. Okay, so this is our datum or datum line. Okay, so question. Itong datum line, is it always the ground? No. The datum line can be decided kung sino yung nagsosolve. It's up to you. It is not necessarily the ground. You have to decide kung saan yung datum point or datum line na magiging convenient sa calculation mo. Okay, so it's not always the ground. Okay, so let us start solving the problem. So we know that energy is equal to pressure head muna. So we have pressure over unit weight plus our elevation head plus our velocity head. So we have velocity squared over 2G. Okay, so substitute natin yung mga values natin. So we have energy is equal to our pressure, which is 5 kilopascal. No? So we have 5 kilopascal over our unit weight. Our unit weight is the unit weight of water. The unit weight of water is 9.81 kilonewton per cubic meter. So yan ang unit weight ng water. Now, how did we get that? The unit weight is equal to the density of the material times the acceleration due to gravity. Okay? So for water, we have the unit weight of water is equal to the density of water, which is 1,000 kilogram per cubic meters, times the acceleration due to gravity, which is 9.81 meters per second squared. Okay, so meter per second squared. So we have here kilogram meter per second squared. So 1 kilogram meter per second squared is equal to 1 Newton. Okay, so our kilogram meter per second squared will be cancelled out. So, ang maiiwan sa ating unit dito is our unit weight, will be 9.81 times 1,000, which is 9,810 Newton, okay? So we can convert that to 1,000 Newton to 1 kilonewton. So let us divide that to 1,000. So we will have 9.81 kilonewton per cubic meters. Okay, so dyan natin nakuha tong value na to. Okay, so this is expressed in kilopascal. So let me convert this into kilonewton per square meter. So 1 kilopascal is equal to 1 kilonewton per square meter. Okay? So tignan muna natin yung unit natin dito para di tayo mahirapan. Kilopascal will be cancelled out. Kilonewton will be cancelled out. Square meter will be cancelled out. So ang matitira is meter. Okay, so this will be the unit in the numerator. So our pressure head is having a unit of meters, as you can see right here, diba? So our elevation head plus Z. So yung position ng ating fluid is 2 meters from the ground, which is our datum line. So we have here 2 meters plus our velocity head, no? So our velocity squared, so ang given natin for velocity is 10 meters per second. So we're going to square that. Then 2 times our acceleration due to gravity, 9.81 meters per second squared. So we already know that the unit of the velocity squared will be square meter per second squared, and we have here meter per second squared. So our unit here will be in meters also, no? Okay. So this means that we have energy is equal to, let us use our calculator now. Okay, so we have here 5 divided by 9.81. Okay, plus 2. Then plus we have 10 squared divided by 2 times 9.81. Okay, so we have here 7.607. No? So our energy head is equal to 7.607 meters. Okay, so let me box our final answer here. So I hope naging clear sa atin kung paano natin nakuha yan. Ano? Now we have our second problem here. In here, we have to calculate the velocity of water flowing at point 2. So ito yung ating point 2 and this is our point 1. And from the flow of our fluid here sa point 2, we have an elevation of 3 meters. No? So katulad nung nabanggit natin kanina, if we have a triangle right here, it means that the surface of water is exposed to the atmosphere. So that means we have an open tank container here. Okay? We also call that a free water surface. No? So that means if this is exposed to the atmosphere, ang ibig sabihin, our pressure here at point 1 is equal to 0. Okay? Our gauge pressure is equal to 0. Now, we are talking about big tank here na. Hindi lang to scale yung ating drawing. But we are talking about big tanks and small pipe right here. So, ang kailangan nating makuha is yung velocity at point 2. Ang kailangan nating makuha. Now, if we are working with Bernoulli's energy equation, we are saying that our energy at point 1 is equal to energy at point 2 provided that we have a continuous flow. So our energy at point 1 is equal to the energy at point 2. Okay? So, let us have our equation. Pressure at point 1 over the unit weight plus elevation head at point 1 plus velocity squared at point 1 over 2g is equal to pressure at point 2 over unit weight plus elevation head at point 2 plus velocity squared at point 2 over 2g. Okay, so yan ang ating equation. So, let us try to determine yung mga values natin. What is the pressure at point 1? So, since this is exposed to the atmosphere, that means our pressure at point 1 is equal to 0. So, this is equal to 0. Okay, so what is the elevation head at point 1? So, in here, I'm going to use this as our datum line. Okay? Because ito ang ating given relating yung position ng ating point 2 sa point 1. So, that means our point 1 is 3 meters above dito sa ating datum line. So, as I said, it is not always the ground. You can put it below, you can put it above, it's up to you. So, that means our Z1 here is equal to 3 meters. So, we have 0 plus 3 meters plus, so what is our velocity at point 1? Okay? So, katulad ng binanggit ko kanina, we are talking about a very big container here at meron lang tayong maliit na pipe dito. So, in that case, our velocity is equal to 0 at point 1. Okay, so wala tayong velocity sa point 1. Well, you might ask, paano nangyari yon? Kasi habang nababawasan yung ating fluid dito, ito namang fluid natin dito is bumababa. So, therefore, we have velocity dito sa ating point 1. Well, that is true. Meron tayong velocity because it's moving downward. But if we are going to calculate that, comparing sa velocity natin dito sa point 2, that will be negligible. Napakababa ng value niyan compared dito sa value ng ating velocity dito sa point 2. So that is why if we have that case, our velocity at point 1 will be equal to 0. Okay? It is because of the speed na masyadong mababa itong velocity dyan. So that will be 0 for now. So we have here velocity at point 1. Our kinetic energy at point 1 will be equal to 0. Okay. So this is equal to, what is the pressure at point 2? So in here. So as you can see, at point 2, it is also released to the atmosphere. So nakalaya yung ating liquid dito, no? You might ask kasi, no, katulad na pag-aralan natin sa pressure in relation to the location niya, no? Kasi dito, meron tayong liquid dito, no, up to this level of the tank. So that means, merong mabigat na tumutulak sa ating liquid dito, kaya nga nagpo-flow siya. Okay, so we are considering this pressure na ginagawa nitong ating liquid. So, of course, we have pressure in here. Lalo dito sa point na to ng pipe natin, we have a pressure here. However, ang pinag-uusapan natin is yung pressure dito sa point 2. So, at this point, na-release na natin yung pressure ng ating fluid. So, nakalaya sa pressure yung ating fluid, no? So, that is why our pressure at point 2 is equal to 0. Okay? So, it is no longer acting based from the internal pressure natin. It is now acting based from the pressure of the atmosphere. Okay, so I hope that is clear. So that means our pressure at point 2 is also equal to 0. Okay, so this will be 0. So we have here 0. Plus, what is our elevation head at point 2? So this is our datum line. So our point 2 is in our datum line. So therefore, our Z2 is equal to 0. Now, ito yung kailangan nating makuha, yung ating velocity at point 2. So we have velocity at point 2 squared over 2 times G. Our G is 9.81 meters per second squared. Okay? So we have 3 meters times 2 times 9.81 meters per second squared is equal to velocity 2 squared. Okay? So, therefore, we have 3 times 2 times 9.81, which is equal to 58.86. No? So, our V2 is equal to the square root of 58.86, okay, meter squared per second squared. So, unit natin here, meter times meter will be meter squared. So our velocity at point 2 is equal to the square root of 58.86. So we'll have the square root of, okay, our answer, which is 7.67 meters per second. So 7.67 meters per second. Okay, so now we got the velocity at point 2. Okay, so I hope maliwanag, no, kung paano natin siya nakuha, and you already should have understand kung paano nakukuha yung mga values natin base sa ginawa nating analysis. But to understand this more, let us move to the next problem. Okay, so now on this problem, meron tayong closed tank. Kaya nga meron tayong pressure gauge dito, no? So it is clear that we have pressure right here. We have to determine the pressure at point 1. So katulad ng sinabi ko, meron tayong pressure dyan. So yan nga yung kailangan nating makuha ngayon. We have a pressure here, which is pressure at point 1. Now, kung nakikita ninyo, mas mataas yung location ng ating point 2 kesa sa location ng point 1. So kapag wala tayong pressure dito, walang tutulak dito sa tubig natin para mag-flow papunta dito sa taas. Okay? Dahil mas mataas yung location niya. Pag nasa baba siya, you don't need that dahil magpo-flow siya due to gravity. No? Meron tayong atmospheric pressure na gumagana dyan at meron tayong water na dumadagan sa ating liquid sa ilalim. So, since mas mataas yung location niya, you will need a pressure para maitulak yung tubig natin palabas. Diba? Ganun yun. So, we have our given here, the elevation of our water from this point, which is 10 meter, and up to that point, we have 20 meters. We have the diameter of the pipe, which is 50 millimeters. And our fluid here is water. And also, we have volumetric flow rate here. Okay, so dito sa ating point 2, our water is flowing at 13.6 liters per second. So, dahil naka-liters tayo, kailangan natin yan i-convert into cubic meters para magamit natin sa ating equation. So, dapat aware tayo sa ating conversion factor. And we should know that 1 cubic meters is equal to 1,000 liters. So, yan ang gagamitin nating conversion factor. Okay, so gagamitin natin yung Bernoulli's energy equation. So, the energy at point 1 is equal to the energy at point 2. Okay, provided that we have a continuous flow. So, therefore, our pressure head at point 1, okay, plus our elevation head at point 1, plus our velocity head at point 1 is equal to pressure head at point 2, plus elevation head at point 2, plus velocity head at point 2. Okay. So again, i-analyze natin yung ating condition. In point 1, we have a pressure. Pero hindi natin alam. Yan nga yung kailangan nating makuha. So we have P1 over our unit weight plus our elevation head, no? Yung location ng ating fluid at point 1. So where will be our datum or datum line? So it's up to you. Katulad ng sinabi ko, pwede nyong ilagay dito, pwede nyong ilagay dito sa taas, or pwede ring sa ground. Okay? Or dito sa level na to, I mean, not on the ground. So I will use this as our datum line, no? Which is from this point, our point 1 is 10 meters from here. So our Z1 is equal to 10 meters. Plus our velocity at point 1. Okay, so katulad ng sinabi ko kanina, we have a big tank here at maliit lang yung ating pipe that is only 50 millimeter diameter. So maliit lang yung opening ng ating pipe. So therefore, our velocity at point 1 is equal to 0. That will be negligible, no? Okay, so we have here our velocity at point 1, which is 0. So this is equal to what is the pressure at point 2. So ito yung ating point 2 and it is exposed to the atmosphere. So nakawala or na-release na yung ating pressure. So therefore, our velocity, our pressure at point 2 is equal to 0. Okay? So we have here 0 plus our elevation head at point 2. So from this datum line up to here, sa ating point 2, we have 20 meters. Now, how about our velocity square, no? Our velocity head, I mean. Paano to? We don't know velocity. Pero alam natin yung volumetric flow rate. So, kunin muna natin yung ating velocity using the volumetric flow rate. So, paano natin gagawin yan? No? So, we know that volumetric flow rate, which is Q, is equal to the velocity of the fluid multiplied to the cross-sectional area. Okay, so therefore, the velocity is equal to the volumetric flow rate divided by the unit area. Diba? So let us now try to solve using this equation. So we have to use this conversion factor dahil naka-liters tayo. No? So our Q is equal to 13.6 liters per second. So we have V is equal to 13.6 liters per second. So we're going to convert that to cubic meters. So we have in 1,000 liter in 1 cubic meters. Okay, so divided by our cross-sectional area ng pipe natin. No? So our pipe is having a diameter of 50 millimeters. So it's a circular pipe. So therefore, our formula here for cross-sectional area will be pi over 4 times the diameter squared. So, ano nga yung diameter natin? So, let me use a bracket here. Our diameter is 50 millimeters. So, we'll convert that to meter, 1,000 millimeters in 1 meter. So, we will be squaring that. So, this is the area or cross-sectional area of our pipe kung saan nagpo-flow yung ating fluid, no? So, therefore, our velocity is equal to, let us use again our calculator, no? Okay, so, we have 13.6 divided by 1,000 divided by pi times 4. Okay, then we're going to divide that to the squared of 50 divided by 1,000. Okay, we're going to square that. So, we have a velocity of 6.9264. So, 6.9264. So, ano yung unit natin dito? Let's check kung ano yung unit natin. Our liters will be cancelled out. Millimeter will be cancelled out. So, denominator natin is in square meter. Okay, but our numerator is in cubic meter. So, we have meters on the numerator. Sorry, I'm going to use white para mas malinaw. We have here meters and we have second here as a denominator. So, our velocity is equal to 6.9264 meters per second. So, substitute natin yan dito. No? We have 6.9264 meter per second. We have 6.9264 meters per second squared over 2 times the acceleration due to gravity, 9.81 meters per second squared. And we know that our unit here will be in meters, no? So, our unit will be cancelled out. Our unit will be in meters dito. Okay, so let us rewrite our equation. Our P1, we don't know, divided by our unit weight. So, ano nga ulit yung unit weight ng water natin? Na-compute na natin yung kanina. The unit weight of water is 9.81 kilonewton per cubic meters. Pa? Plus 10 meters, okay, is equal to 20 meters plus our kinetic or velocity head. So, let us calculate for that. So, we have 6.9264 squared divided by 2 divided by 9.81. So, we have 2.445. Okay, so we have 2.445 meters. Okay, so therefore we have pressure at point 1, 9.81 kilonewton per cubic meters is equal to 2.445 plus 20 minus 10. Okay, minus natin to. Itong nasa left side ng equation. So we have 12.445. So we have 12.445 meters. Okay, so therefore, our pressure at point 1 is equal to 12.445 meters times 9.81 kilonewton per cubic meters. So, ano yung magiging unit natin dito? This meter will be cancelled out. Ang maiwan sa denominator is square meter, di ba? So, let us calculate. We have 12.445 times 9.81. So, this is equal to 122.088. Okay, so we have P1. Oh, sorry, again, we'll use white. So, we have P1 is equal to 122.088, okay, kilonewton per square meter. Okay, this is square meter, sorry. Okay, so 1 kilonewton per square meter is equal to 1 kilopascal. So 1 kilonewton per square meter is equal to 1 kilopascal. Okay, so our unit here will be cancelled. Kilonewton per square meter will be cancelled. So our answer here, the pressure at our point 1 is equal to 122.088 kilopascal. Okay, so we have now our final answer here. Okay, so now we are down to our last problem. Now we need, oh sorry, we have wrong notation here, no? You have to disregard itong question. Let us try to, because you know this is already problem 4. We have problem 3 here. This is problem number 4 now, no? And we have wrong question here. Now, moving on, this is wrong, so we will just try to solve itong ating given dito, no? So we have given value. So we have triangle here, so that means we have an open tank container, open top container here. Okay, so having this value, we will try to use the Bernoulli's energy equation, and based from that we know that energy at point 1 is equal to energy at point 2. Okay, so that means we have pressure at point 1 over unit weight plus the elevation head at point 1 plus velocity head at point 1 is equal to pressure at point 2 over unit weight at point 2 plus elevation head at point 2 plus velocity squared at point 2, no? Okay, so let us again try to analyze. Our pressure at point 1, okay, so point 1 is exposed to the atmosphere, so that means our pressure is equal to 0. So, what is the location of our point 1, our elevation head? So, saan ang gagamitin nating datum point? So, let me use this as datum line natin para mas madali nating makita yung location, no? So, this is our datum line. Okay, so based from that, alam natin yung value ng ating elevation head for point 1. So, our Z is equal to 240 meters. So, let me rewrite. Our pressure head is equal to 0 at point 1 plus Z1, which is 240 meters. Okay? Plus, what is the velocity at point 1? So, as I said earlier, meron tayong malaking container and we only have a small pipe here. The diameter is only 100 millimeter, no, compared to the volume of our tank. So, our velocity at point 1 is equal to 0. Okay? So, let me write that here. Our velocity here is also equal to 0. So, this is 0 is equal to, what is the pressure at point 2? Okay? So, our point 2 is exposed to the atmosphere. So, therefore, our pressure at point 2 is equal to 0. Okay, so we have here 0 plus our Z2. Our C2 is located on the datum line or datum line. So therefore, our C2 is also equal to 0. Plus, we have our velocity given here. We have 60 meters per second squared over 2 times our acceleration due to gravity. Okay, so makikita natin, no? We have a lot of zeros here. So we will have only 240 meters is equal to 60 meters per second squared over 2 times 9.81 meters per second squared. So, ang dali lang, no? Nakuha na agad natin yung ating values. Pero lumalabas dito, wala tayong unknown. So, hindi natin alam ano bang kukunin natin dito. Okay? Meron bang problema dito sa na-solve natin? Yes, there is a problem. Because if we calculate this, let us try to calculate. We have 60 squared divided by 2 and divided by 9.81. So we have here 183.49. While here we have 240 meters. Paano nangyari yan? We have 240 meters here, we have 183 meters here. So, hindi siya equal. Sabi natin sa Bernoulli's energy equation, kailangan equal ang energy natin sa point 1 and point 2. So, we have to analyze ano ba yung nangyari. Here, we have an open top container. So, magpo-flow siya, okay, dahil mas mababa ang location ng ating point 2. So, our elevation head here is higher than the elevation head dito sa point 2. Okay, so our potential energy here at point 1 is higher than the potential energy at point 2. So, magpo-flow yung ating tubig pababa. Now, hindi naging equal yung ating energy. Mas mataas dito compare dito. While according to Bernoulli's equation, dapat equal sila. So, anong nangyari? Okay, so we have the energy head dito sa ating point 1, which is 240 meters. Energy head sa ating point 2, which is 183.49 meters. So, bumaba yung ating energy, no? From 240, bumaba siya to 183.49. So, it tells us that there are energy that is lost. And we call that as the head loss. So, the head loss is the energy loss between point 1 and point 2. Okay, so yun ang ibig sabihin yan, guys. Merong nawala na energy. Kasi dapat equal sila, no, according to Bernoulli's energy equation. So, how are we going to get that now? Ano yung head loss? Actually, our equation here will be energy at point 1 minus yung nawalang energy, which is the head loss, is equal to energy at point 2. Okay? That means if we are going to transpose, our head loss is equal to, okay, energy at point 1 minus energy at point 2. Okay? So, our head loss is equal to energy at point 1, which is 240 meters, minus the energy at point 2, which is 183.49 meters. So, our head loss is equal to, okay, 240 minus 183.49. Okay, so our answer is 56.51. So we have here 56.51 meters. So yan ang ating head loss. Okay, so basically you learn how to analyze yung problems for Bernoulli's equation, and we also learned how to calculate for the head loss. Okay, so I hope you find this lecture useful and nakakuha kayo ng mga techniques kung paano kayo magso-solve ng mga problems involving Bernoulli's energy equation. So on our next topic, we will discuss more about fluid mechanics or fluid flow, no? So with all of that and more, I will see you in our next video.